So we're going to be doing a tag team kind of version of this talk. Where I'll kind of intro some stuff, and then Ross will take over in the middle, and then I'll jump back in at the end. We'll see how it all goes. We're saying that this is the tallest talk at NASA's. So the Flyover Country app is an app that's supposed to tell you what you're flying over, is the idea. And it's available for both Android and iOS already, so you can download the version that's out right now. And that works pretty well. You'll see, I'll give a little demo about how to use it here. But we're working on a new version to be coming out in the next couple weeks. So that should be fun. Ooh. There we go. Let's just go with it.
We're good.
Seems fun. Cool. So yeah, it's available already, and you can try it out. Funded by National Science Foundation as kind of an outreach tool. So the idea is that there's a wonderful view from the airplane window that we've all experienced, most of us, if we flew, experienced recently. And I don't need to tell you guys twice that satellite views are beautiful. This is like the best satellite view, right? It's as close to space as you can get. You're basically on the ISS when you're in a plane, as close as you're going to get, essentially. So it's pretty cool. It's a pretty wonderful thing that we have. So I come from a geoscience background, so I have some kind of a way to interpret some of these landforms. So like I know that those are the sand dunes of Nebraska and what that means about the last glaciation and like how this exists. But most people don't have that view. And so the goal of the app was to bring that view to people who are encountering this really beautiful view without having access to information to augment that and let them learn and become excited and see the cool science behind the landforms that are below them. So the basic idea of the app is that you can download a strip of interesting area, right? So you tap your start point, you tap your end point, so in this case, San Francisco and Minneapolis, and it'll download that strip of information. It goes out to several different geoscience databases, pulls in geologic maps, fossil locations, landform information, articles about those landscape features, and things like ocean core samples. If you're flying over the ocean, you can read about some climate studies that have been done based on the sediment at the bottom of the ocean, that kind of thing. And so then that saves it all to your phone so that you don't need a connection while you're on the airplane or wherever you may be. And your GPS works fine in airplane mode. You can sit in the window and track your progress across wherever you're flying to and read about those things below you. So this is kind of a view of zooming in onto the app and clicking an article and reading that. And all that is saved for offline use. So this has kind of been a good thing for NSF. They've kind of been happy with us. We've been able to get these geoscience databases that have all this amazing content that's not being visualized in a lot of ways, and pulling those together onto the same map so they're kind of both accessible to people by just tapping on a map. They can see this information that these databases even exist, and also that maybe as a scientist, once you're layering these different data types from various subdisciplines of geology and geoscience onto the same map, you can kind of get some new insights from that kind of thing. So we've had some good, few downloads. Depends who you ask if that's a lot or a little, but a few different news stories. It's been fun. So as we've built this, though, we realized it was kind of a tool also useful, potentially, the same idea, going out to these data repositories and pulling in data, saving it to the phone for use wherever. On the ground, as a researcher exploring a new field area or as an educator on a field trip, you can use these capabilities to go out and find things out about the landscape that you're now interested in or going to study. As you take new measurements, you can compare them against old while you're out there on maybe an expensive place that took you a long time to get to. You don't have time to go back to the hotel and compare it against the data that already exists. So as we've moved into this field of trying to visualize more complex data types, instead of maybe just dinosaur fossils, we want to have mollusks or something. Somebody is interested in mollusks in the community of geoscience, so they want to visualize that kind of thing in their field area. We've encountered that there's a lot more data types in the world that aren't just point data, right? So that's where Roth comes in. He's working on some multivariate temporal visualizations here.
Cool. Oh yeah. So the problem with visualizing these big multivariate spatiotemporal data sets is that it's also very hard on a mobile screen, and so that's kind of what I'm looking at. For example, we're going to take a look at pollen in a core, sediment core, for example. There's a lot going on, but just focus on the pollen and the core itself. So pollen and sediment settle at the bottom of a lake every year, and this is pollen from trees, from other vegetation, flowers. And so every year, like in this core here, on the left, it looks like tree rings, and so that's where the temporal aspect comes in. So you've got multiple different types of pollen, your multivariate, and the temporal aspect of being a lot over time. And so one reason to study pollen is because it tells us about nearby vegetation, land cover, which can in turn give us a good picture at temperature and climate of the year, which is really important for our understanding of climate change right now. And so this is kind of what you would look at. This is one visualization for a specific type of pollen over time in that visualization. So this Neotoma database that we're pulling from has just an astounding number of sites. And so they're all visualized as this red dot, which doesn't really tell you much about the data that's actually there. And so if you want to compare sites, you'd have to go into an individual dot and then remember everything that you need to know and then go back to another one. So if we look into one of these sites, would look like this. A single lake core with 12 different pollens over 120 meters, which correspond to a number of years. So comparing each pollen type to another at one single place is fairly easy. But if you have to go back to this and then remember exactly what you saw in that other one, and yeah, you get the point. Educators are interested in certain taxa and how they change over time. So that's one of our prime audiences. But we're not only trying to show this comparison and trying to make this visualization and comparison easier, but we're also attempting to do it on a mobile screen. So, it's basically a piece of cake, right? Or should I say, a piece of pie? Just kidding. This is a public service announcement to try to avoid pie charts, brought to you by the Roth Foundation for better data visualization. So, to get a grasp of what is going on in terms of current data visualization in the field of paleoecology, we conducted a quantitative content analysis of all of the visual figures from 100 plus papers in the Neotoma database, which is about over 600 figures. We looked at all the types of visualizations as well as visual variables and the data types, but we really just focused on what they're actually using to show this. So some visualizations provide solutions to multivariate data in the form of like small multiples. So if we see that was the number in the top range of all the visualizations. And so we can look at these, and if you think back to the red dot example, having all of these small multiples to show you something about the pollen site is not great. It takes up a lot of space. So thinking about all of these that we saw, we kind of came up with 4 brainstormed solutions. And these are petal plots, radar or star plots, stacked histogram, and flagpoles that could be used on these maps. So petal plot, I'll just talk a little bit about each one. A number of icons, in this case they're leaf shaped, that surround a lat long and are sized according to the data. So radar plots, polygons with points equal to the number of variables kind of stretched along these bike spokes according to the corresponding values. And stacked histograms, pretty self-explanatory for data viz people. A flagpole, the kind of our purest temporal visualization. It's basically stacked area charts with time on the y-axis and value on the x-axis. So these visualizations are good for some things and not so good at others. And so we kind of thought about how some of them are better or worse for mobile, and some of them are better or worse for showing temporal data. And we've got the radar plot over there because each year you could have multiple polygons on a radar plot and it could correspond to different years. So that was kind of our thinking. But and we thought, who would want to see this? And the prime audience for these is researchers and students who want to visualize and compare this multivariate complex data sets. And while the public might not use this, there will be people that probably are interested in seeing this. And so we're keeping all of these personas in mind and want to make this show the complex data well, but also be readable and intuitive. And so one thing, it's hard to adjust for mobile suitability. You can't really adjust for that, but the issue of temporal visualization can be augmented with interactivity. So the presence of a slider bar, for example, can allow you to tween between years, resizing the icons according to the data from that year. So if you were to slide like this for the petal plots, you would see them grow and you'd see them shrink according to the data. And so what we'll be doing is using these visualizations in a map survey to determine their effectiveness, their usability, and just to see if people like them and if they make sense. So, which has been done, usability tests have been done in Flyover Country's past.
Yeah, so the version of the app that you can find in the stores now, kind of shifting back to the app's UI idea here, is not necessarily intuitive in a lot of ways. We found out through a usability study and through just watching people interact with it. And that's for a few different reasons, I think. One of the main things is this first interaction. When you load the map up, when you load the app up, you're presented with a map with no cool information. There's no fossils that you were looking for. There's no geologic maps. There's nothing. There's just a map, and you're expected to know what to do here. And we've made a tutorial that outlines that, okay, you need to tap your start location and your end location, and that's how you can start to load, but that's not an intuitive way to be able to interact with that, it turns out. So people don't discover that. So, but once you've figured out that trick, and I'll go into the ways that we've tried to fix that issue in a bit here, the second problem that you come up with is a workflow issue. So you have to do several things to get to the point where you have this map saved for offline use. So you don't just get it all saved right away. You load your path by checking it out and then deciding that this is okay, I want to save this. So there's a couple steps there that you have to work your way through that aren't necessarily intuitive and very important for the functionality of the app. So the other final thing is starting out, me as a geologist, making a first app, just like winging it. We thought, cool, sidebar makes sense. But as you all know, it's not actually the best way to expose your best features is to hide them away in an invisible sidebar. So there's a solution we've worked on to get rid of that as well. So to combat this first interaction problem, we've added this is our V1, V2 kind of comparison here, and we've moved towards a main fluid floating action button we've decided to call it. So it's this button that kind of overlaps onto the map, only shows up in that map tab, and kind of is asking to be pressed, we hope. And so the first thing that you can get from tapping that is some options that'll come up. You can choose what you're interested in. You care about fossils and geologic maps. Okay, choose those things. You can choose whether you're going to be on the ground or in the sky. In the future, we'll add routing, so you could type in MSP as your airport code to SFO or whatever it might be, and it'll load that path up automatically for you. So you don't have to actually know where maybe Montreal is and find out where it is. It'll just do that for you. So adding things to this screen is our next big move. And so once you've decided on your path origins, you can go ahead and load those things currently by tapping the map. So you tap Minneapolis, tap over to Montreal. That was my flight. And so now the same button is now your key to the next thing. So if there's any point, you just smash that button, that'll get you to the next step is the idea. And so that loads that data down. It pulls it from those different geoscience databases, but the articles and the text there and the map tiles, those are all not yet saved for offline use. So the next thing that you need to do is, or a little tooltip says, is save it for offline. So you need to spend a bit of time, maybe 3 minutes or something, downloading all those map tiles, stashing them away, downloading all those Wikipedia article text, stashing those away, and that's the next key. So there's kind of this workflow that you need to do, and here's kind of an example of that as you work your way through the app's sequence of events here. So you're checking it out, okay, I'm happy with that, choose what to save, and off you go. So the next final kind of problem we're trying to solve is getting things out of this hidden side menu. So we have lots of good content, more than just a map app. So we've got field trip guides, so there's geoscience field trip guides written by professional geoscientists that we've pulled in. So you can go around on the ground and like check out these geologic interesting locations, at least to us. What is that section is actually a really cool one for identifying things from above. So it's kind of like a geomorphic field guide. So when you're looking down at this river that has these bends to it, why does it have those bends? And maybe there's not a Wikipedia article specifically about that river and its bends, but you can kind of understand that geomorphic process through that section. So getting these important things, even the saved stash of all your flights that you've saved that are what you need to use when you're on the plane, moving all that stuff to a bottom tab kind of navigation, easily accessible, easily accidentally discoverable, moving that to the forefront of your interactions with the map is the next big thing there. So here's an example of that. What is that section? You're just over in a different tab, exploring through the map, loading a saved path. All those things are easily accessible in this new kind of paradigm. So got to try out the new version for the first time in the sky on the way over here, which was really nice. There's like frantic bug checking and like complete panic the whole time, but it's pretty fun. It worked well enough, and found some cool things on the way. There's a big impact crater, the Sudbury Basin. It's like 2 billion year old huge impact crater, seismic zone that I didn't know existed in Quebec. And Mount Royal, of course, the big giant old volcano that's the big hill that you guys should go climb just in town here. So lots of cool things to discover. That new version will be out in the next couple weeks. We're trying to get it out by, I guess, next week. So we're going for that. So yeah, try it out. Thanks.